So in the question it is asked the relative abundance of and is higher in living organism as compared to Earth's crust. You know that there are various elements which are present in Earth crust as well as in human body, but they differ in the percentage amount which are present in Earth crust as well as in the human body. So we have to select those elements whose abundance is higher in living organism as compared to Earth crust. So in our very first option it is given carbon and hydrogen. So hydrogen make up about 0.14% of the weight of Earth crust, while it makes about 0.5% of weight of human body. So the relative abundance of hydrogen is more in human body as compared to that of Earth crust. Similarly, the carbon, it makes up about 0.03% of weight of Earth crust, while it makes up about 18.5% weight of human body. So the relative abundance of carbon and hydrogen is higher in living organism as compared to Earth crust. So the relative abundance of carbon and hydrogen is higher in living organism as compared to Earth crust. Let's see our second option, which is given carbon and calcium. So calcium, it makes up about 3.6% of weight of Earth crust, while it makes about 1.5% of weight of human body. So the relative abundance of calcium is less in human body as compared to that of Earth crust, while relative abundance of carbon is higher in living organism as compared to that of Earth crust. So option 2 cannot be an answer. Option 3, that is oxygen and sodium. So the oxygen, it makes up about 46.6% of weight of Earth crust, while 65% of weight of human body. While sodium, it makes up about 2.8% of weight of Earth crust, while 0.2% of weight of human body. So relative abundance of oxygen is higher in living organism as compared to Earth crust, but the relative abundance of sodium is higher in Earth crust as compared to that in living organism. So option 3 cannot be our answer. Option 4, that is hydrogen and silicon. Relative abundance of hydrogen is higher in human body as compared to that in Earth crust, but the relative abundance of silicon is higher in Earth crust, but it is negligible in human body. So option 4 cannot be our answer. So the option which gives correct answer for blanks in the given statement is option 1. Let's proceed to our next question. Question 162. Which says all of the following are nitrogenous bases found in nucleic acid occurring in HIV except HIV is human immunodeficiency virus. The nucleic acid present in HIV is RNA, since it is a retrovirus, and you know that RNA has purine and pyrimidines. So RNA has adenine and guanine, and for pyrimidine, RNA has cytosine and uracil. Thymine is absent in RNA, while uracil is absent in DNA. So adenine, uracil and guanine are nitrogenous bases found in nucleic acid occurring in HIV, while thymine is absent, making option 3 as the answer for our question. So let's proceed to our next question. Question 163. Alanine is. Alanine का structure अगर पहले देखिए, so there is an alpha carbon to which a carboxylic group is attached. Then there is an amino group, one hydrogen group, and R group in case of alanine is methyl group. So this is the structure of alanine. So our very first option says alanine is monoamino dicarboxylic amino acid. Monoamino means it has single amino group. Dicarboxylic means it has two carboxylic acid group. But in alanine, there is only one carboxylic acid group. So option first cannot be our answer. Option 2, that is monoamino monocarboxylic amino acid, means it has one amino and one carboxylic acid group. Option 3, that is monocarboxylic diamino amino acid, means it has one carboxylic acid group and two amino group. But in alanine there is only one amino group, so this cannot be our answer. And option 4, it said alanine is basic amino acid. Basic amino acid has extra amino group, but in alanine there is only one amino group, so this cannot be our answer. So the correct answer for this question is option 2, that alanine is monoamino monocarboxylic amino acid. So the correct answer for this question is option 2. Question 164, non-competitive inhibitors of the reaction. So we have to select the option which gives correct answer for blank in given statement. So first we should know what are non-competitive inhibitors. Non-competitive inhibitors and substrate, they bind with different side on enzymes. And non-competitive inhibitor, once they are bound with enzyme, they make the active site inaccessible for the substrate. अब ऐसा हो जाएगा कि सबस्ट्रेट जो है वो एक्टिव साइट पे बाइंड ही नहीं कर पाएगा. तो रिएक्शन में क्या क्या चेंजेस होंगे? फर्स्ट वी शुड नो द सिनेरियो इन केस ऑफ एब्सेंस ऑफ नॉन कॉम्पिटिटिव इनहिबिटर. जब नॉन कॉम्पिटिटिव इनहिबिटर नहीं है, सो इफ यू प्लॉट अ ग्राफ बिटवीन रिएक्शन वेलोसिटी एंड सबस्ट्रेट कंसंट्रेशन, तो जैसे जैसे सबस्ट्रेट का कंसंट्रेशन बढ़ता है रिएक्शन वेलोसिटी बढ़ती रहती है, क्योंकि ज्यादा से ज्यादा सबस्ट्रेट मॉलिक्यूल फिर एंजाइम से बाइंड होंगे और फिर वो प्रोडक्ट में कन्वर्ट होंगे, तो रिएक्शन वेलोसिटी increase होती है. But after some time, once the Vmax is achieved, there is no further change in reaction velocity. Why? Because at Vmax, all the active sites of enzyme molecule, they are occupied by the substrate. So no free enzyme molecule is available to bind with more substrate. So once the Vmax is achieved, there is no further change in reaction velocity. And you all know that substrate concentration at which half of the Vmax is achieved, and we call it as Km value, also known as Michaelis-Menten constant. तो ये तो हुआ नॉर्मल सिनेरियो में. अब बात करते हैं तब जब नॉन कॉम्पिटिटिव इनहिबिटर्स है. नॉन कॉम्पिटिटिव इनहिबिटर्स, once they are bound to their respective site on an enzyme, they make active site inaccessible for the substrate. तो अब substrate जो है active site से bind ही नहीं कर पाएगा. But they do not alter the affinity of enzyme for the substrate. So non-competitive inhibitors since they do not affect the affinity of an enzyme for a particular substrate, so the Km value remains unchanged. Whatever the Km value is in the absence of inhibitor and in the presence of inhibitor will remain same. But the number of functional enzyme molecule which can bind with the substrate get decreased. That's why the Vmax of reaction decreases. So non-competitive inhibitors, they decrease the Vmax value since they decrease the number of functional enzyme. So if we plot a graph between reaction velocity and substrate concentration in the presence of non-competitive inhibitor, तो मैंने क्या बताया था कि Vmax value decrease हो जाती है due to decrease in number of functional enzyme molecule, but the Km value, it remains unchanged even in the presence of non-competitive inhibitors. So in the question it is asked, non-competitive inhibitor will decrease the Vmax value, making option 4 as answer for our question. Talking about the rest of the option, increase the Vmax value. This cannot be our answer since it decreased the Vmax value. Option 2, that is increases the Km value. Non-competitive inhibitor, they neither increase nor decrease the Km value. So option 2 and option 3 cannot be our answer. So let's proceed to our next question. Question 165, which says all of the following are derivative of tyrosine except option first, thyroxine, which is the thyroid hormone, and it is produced from tyrosine. So this cannot be our answer. Option 2, that is adrenaline, also known as emergency hormone, and it is a derivative of tyrosine. So this cannot be an answer. Melanin, which is skin pigment, and it is derived from tyrosine. So this cannot be an answer. Option 4, that is melatonin. Melatonin is derived from tryptophan? Not from tyrosine. So the correct answer for this question is option 4. So let's proceed to our next question.